First off, I got emailed a bit of code that we'll take a look at. And if I run this, comes up and there's an error. 5.9. Parking charges. Okay, so we got a $2 minimum fee to park for up to 3 hours. An additional 50 cents per hour afterwards. $2. $2 initial for 3 hours. 3 hours, 50 cents after. Per hour after. I programmed to calculate and print parking charges for each of the 3 customers who parked their cars in this garage yesterday. You should enter the number of the hours parked for each customer. Your program should print the results in tabular format and should calculate and print the number of yesterday's receipts. You should have a function calculate charges to determine the charge for each customer. Your output should appear in the following table. So it looks like we're going to ask 3. So we're going to ask for 3. Okay. See if I can get the syntax right. So up here is where I need to put my float and calculate charges. I'm passing in hours. Guess that's it. I can pass in part of an hour. So float hours. Then down here, I'm going to have my float. Then I'm mixing the languages together. I don't know if I need public there or not. Let me just do calculate charges and see. Float hours. So all of this right here is going to need to be down here. Okay. Initially, no matter what, our charge is $2. Not that you need to, but let me just really emphasize that. That's $2. Then it's for 50 cents per hour after those 3 hours. So I need to find the number of hours after that 3. So I'm going to have charge 1 is equal to charge 1. That's my initial $2. Or I could even hard code $2 there. plus, and I need an if statement. If the number of hours is greater than 3. If it's not greater than 3, then no matter what, it's just $2. So then I'm going to say charge 1 is equal to charge 1 plus, I'm going to take the number of hours minus 3 times 50 cents. Okay. So I don't need to, see how close was this? If it's less than or equal to 3, yeah, that's perfect. If it's greater than 3, it's $2 plus 50 cents times, yeah. The code is correct on this, just in the wrong location. Okay, so then up here, I'm going to have my this var1 here. I think I'd probably put inside the curly brackets. And I'm going to have a for loop here for int x equals 1, continue while x is less than or equal to 3, and x plus plus, because we're going to have 3 customers. And I need to probably ask him, what do I need to ask him? Okay, I'm assuming it's car 1, car 2, car 3. I need to ask him for hours. I got this called var1 here. I'll leave it as var1. Let's see, printf, input, hours, scanf, what in the world's float? Is it %f? I think so. No memory. var1, and that'll bring in my hours. So then, how in the world did I do this? I don't think I can now, the way I've designed it. Okay, well, hours 1, hours 2, hours 3. Problem with how I designed it is I can print it in tabular format, but there'll be that printf that appears in the middle. And it'll also be the input that I put in. So it won't look nice and pretty in a table format. We haven't covered arrays yet, so that's not really a possibility. So I'm going to have 3 separate printf statements here. Input hours for car 1. And it could be they just wanted you to hard code it. Scanf, %f, var1. I'm going to repeat this. So input hours for car 2, that'll be var2 or var. I'm going to change that to hours 1, hours 2, hours 3. There's actually nothing wrong with that variable name. I just didn't match what I started changing it to. Okay, so now I should have hours 1, hours 2, and hours 3. So if I do a printf, and I want to do a car, I don't remember which slash it is. I'll try that one. /t hours /t charge /n, and then I'll do printf 1 /t percent dot 1f /t percent dot 2f /n, and then I'm passing in hours 1, comma, and then I'm doing a calculate charges, and I'm passing in my hours 1 there. Okay, so now all this I think is pretty obvious up here. I'm hard coding 1. Then I got a tab going to the next horizontal tab. This %1f, that's going to be my hours 1. And it appears like they're rounding it to 1 decimal place. The what? We forgot to put 3 on 1. 3 on 1? Like car 1. Oh, yeah. Thanks. And then this %.2f here is rounding at 2 decimal places. Now there's even more in this, because this looks like it's right aligned. So we'll have to play with that a little bit. And then I'm calling a function from within here. So you don't have to have a separate variable. You can call the function from within there, and then it'll plug in the result, the %.2f here, assuming we're returning a float, which we are. I don't know why I just don't do a Control-C. Do I got a /n? Yeah, I do. Okay, so I'll paste that, and then I'll paste another one. This will be hours 2, hours 3, 2, and 3. Assuming I don't have any mistakes, we'll see. Didn't like something. Oh, there's a semicolon here. Can't have a semicolon after the main void. Input hours for car 1, 1.5, 4, and 24. 1.5. That's not good. Let's see what I did wrong. Ampersand hours 1. And simple. Okay, so let's run this. 1.5, was it? 4.0. 4 and 24? Yeah. And did it work? $2.50, $10. Uh-oh. I can't beat $10. It's for up to. Is it $2 per hour? No. This is the maximum charge for any given 24 hours. Oh, okay. So if I actually read, that makes sense then. Where in the world's my program? Okay. So down here then, if hours or charge 1 is greater than 10, then charge 1 is equal to 10. Okay. We don't got a total, but that's easy. I'll add a total. Set my total equal to 0. Then after I bring in each, what am I totaling? Both the hours and charge. So I need not only total hours, I need total charge. Okay, so then I guess I do need the yeah. Total hours equal to total hours plus hours 1. Down here, I'll have total hours equal total hours plus hours 2. And down here, I'll have total hours equals total hours plus hours 3. Now, I could call this over and over, which isn't necessarily good. But since we got such a short program, I don't think it's really that inefficient. So I'm going to simply say total charge is equal to calculate charges hours 1 plus calculate charges hours 2 plus what in the world? Hours 2 plus calculate charges hours 3. And then down here, I want to do a printf. What does that say? It says total /t percent dot still 1 and still 2, 1 decimal place. I'm rounding it to /t percent dot 2f, 2 decimal places /n for the new line, comma total or total hours, comma total charge. And let's run that. 1.5 for 24. 1450 and 29.5. Yep. It's not right aligned though, so we'll go back and correct that. Say 6. Put a 6 here. 6 here. 6 here. 6, 6, 6. And down here, I guess 6 and 6. And 1.5, 4, and 24. And now it's right aligned. And that'd be our program. Questions on any of that code? Okay. So let's take a look at the next chapter. Arrays. In Excel, I can put some numbers into my first column. So I'll put in 7, 2, 8, 9. I got 4 numbers. This is called a list of numbers. You might even call it a vector. Some say that. In programming, we oftentimes refer to that as an array of numbers. It's a list. That's what an array is. Now with this, we'll want to maybe sum all the numbers in it. Maybe we want to go through it and reduce each one of them by 1. So lots of different things we can do with this. This concept of arrays even goes further, because arrays is something you put in temporary memory when you run your program. But it could be that it's a database. A database is a little bit more than that, because it not only has just one variable, but has many variables, but you have row after row of them. So same principle. In this chapter, objectives. In this chapter, we'll learn to use array data structure to represent lists and tables of values, define an array, initialize an array, refer to individual elements of an array, to define symbolic constants, pass arrays to functions, use arrays to store, sort, and search lists and tables of values, and define and manipulate multidimensional arrays. We've already talked a little bit about that. Array is a group of contiguous memory locations that all have the same type. So they're all integers, for example, or all doubles. We have to refer to the position number. And bracket is how we can refer to the position number. Now this is how this is referred to. It starts with 0 and then goes on up. So for like this over here, when we refer to the position of this is going to be our 0th position. This will be our first position. This will be our second position. And this will be our third position. I'm sure I've read about it sometime in the past, but it's not one of those things that I really care to even remember, so I couldn't tell you why these start at 0, but they do. No matter what programming language you go into, the arrays, lists, indexes, whatever they call them, Python has like 3 different names for them. Tuples, I can't remember the other 2 names, that's bad. But they got different names. Same idea, though. They start at index 0. So when you're trying to go through here and you're doing a for loop, you're going to go from 0 to 3. You will not go from 1 to 4. And that refers to subscript. We'll see that. Okay. Defining arrays. The following definition reserves 12 elements for integer array C, which has subscripts in range 0 to 11. So this is actually how many elements you're going to have. So if we wanted to program in adding these 4 numbers together, then let's go and do that. So I'm going to come up, delete some items here. We got our int, C, and then bracket 4, close bracket. That's defining the size of it. Now how I would load those in is I'd say my 0th position, C bracket 0, close bracket. So that's referring to my first position in my list, my array, is going to equal to be the number 7. My second position, which is index 1, is going to be 2. My third position, which is index 2, is 8. And then that'll be 9. So that's how you initialize them. Now there's alternative ways to initialize them. where you can do them all in one line. There's also where you can put this in a for loop. And I'll program in the for loop after we look at this way of doing this. And then I'll just refer to the other method. I'm assuming it'll be in the PowerPoint. You can have multiple definitions. So you can declare an array called B, comma, and an array called X. This is a kind of important item here. Like any other variables, uninitialized array elements contain garbage values. So if you're going to use them, you should set them equal to 0 initially. Here they're initializing it with a for loop, and that's what I'll show here in a minute. There it is. That's what I wanted to show you. See, this is the other way you can initialize them. Remember how I said you could do it all in one line? So you can do your int in and then for inside of brackets equals beginning curly bracket, your 4 numbers, closing curly bracket. If you're going to hard code values, that's the best way to do it. How many times are you going to hard code values? Never. So that's why I'm not going to focus on that. But that is the other way of doing that. Now, if I wanted to add these together, then I need a new variable called sum. And I'll set equal to 0 initially. Now, the brackets here indicates that C is an array. Sum does not have brackets, so it's not an array. And I can say sum equals to C0 plus C1 plus C2 plus C3. And then I can do a printf. The sum is percent C. We're dealing with integers. /n and then sum. Now, if I run this, 17, 19 should give us 26. Then we get the sum is 26. Now, again, that's not the best way. We've hard-coded everything. It's each time we'd have to do it, we have to change numbers and rerun our program. Better way is to ask the user for the numbers. So maybe the better way, I'm going to say printf, how many numbers do you have? You could also do remember how we looked at the sentinel control? You could do that with a while loop, in or -1 when you're done. Problem with that is you would have to say the -1 is not a valid value. Maybe it is a valid value here. So then how do you program it such that, you have to do that flag? It's really easy when -1 is not a valid value. This is probably the easier way. So I need a variable to keep track of how many I have. So I'll call it count. And I'll say scanf %d and then count. And right now this is hard-coded for 4. So if they put in 6, it won't work. So I probably should say maybe up to 4. Because I don't want more than that. Up to and including. Something like that. Okay, so bring that in. And then I'm going to have a for loop here for int x equals 0. Continue while x is less than, or let me think. If they put in 3, meaning I have three numbers. I want to go from 0 to 2. So this will be, that'd be right. X is less than count. And then X plus plus. Printf, input, %d of %d /n. And I'll say number. Then comma, and then this is going to be my index, which is X, and comma, and this will be my count. But there's a problem with that, because that'll say input number 0 of 3. User won't know what in the world that means. So I'll put a +1 here. Now I'm going to bring in the number. So I'll create a temporary variable called temp. And temp is going to equal to scanf. Wait, wrong language. Scanf %d and then temp. And then I'm going to assign C and then X equal to temp. So I'm bringing the number in, I'm assigning it to a temporary variable, and then I'm going to put it into my array. Now you might be looking at this and say, well, yeah, boy, you're making this a lot more complex. It's pretty simple up here. Yeah, but this is hard-coded. Now when this gets done, I should have all my values loaded in. So now let's get the sum. I'm going to reuse the same variables above. So I'll say sum is equal to 0. I'm again going to loop through int x equals 0, x is less than count, x plus plus. And I'm going to say sum is equal to sum plus c of x. I don't know, I just don't type that again. It's just as fast for me. And then I'll print out the sum. Now let's run this, see what kind of errors I have. How many numbers? Sum is 26 on that one. How many numbers do we have? I'll say I'll have 4 numbers. It says input number 1 of 4. 7, 2, 8, 9. So 7, 2, 8, 9. It says sum is 26. If I run this, and I'll put in 20 for my numbers. Input number 1 of 20. So put in 3, 4, 2, 1, 7, 9, 11, 3, 4, 5, 6. I'm not very good at math, basic math, but I'm pretty sure that doesn't add up to that, does it? You know, if I come up here, that's 7, 9, 10, 17, 26, 36, 37, 40, 44, 52, 61, 71, 73, 93, 95, 95 plus 20, I don't know, plus another 20. It's not equal to that. Is that a very robust program right there? No. If I'm going to actually hard code this at a size of 4, I don't want you to be able to go beyond 4. So that'd take a little bit more cleaning up on this. These are ways that if you have somebody that programs poorly, then people can, do weird things with the system. More clever people than I am. I wouldn't know how to overload a C program so I could hack in. But yeah, they worry about things like that. So, any questions on what I've shown you so far? There's one college here in Kansas, besides us, that's using Blackboard. And well, there's probably more than one, but the one in particular I'm thinking of, and they're looking at going to Canvas, and they're having so many errors with their system. It's just I think that daily they have critical updates. They have to bring it down so Blackboard can get in and take a look at it. Canvas is pretty stable and so forth. Why is Blackboard having so much trouble? Yeah, they have bad programmers. It just amounts to that. They have programmers don't have no clue what they're doing. You know, they write things like this and don't think of the consequences. Don't spend time testing it, and they're going to lose that college's business because they're planning to go into Canvas. Canvas, on the other hand, has some fantastic programmers. Okay. Let's see if there's anything else I skipped over here now. Pretty much after this is what they did. They're looping through. They initialize everything to 0. Oh, they're setting equal to 0. So that's exciting. So they haven't got to where I was. Okay, so again, you can initialize it all at once there. Static. Well, it's important to remember the arrays are not automatically initialized to 0. You have to set equal to 0. That's true with any programming language. You should never assume that a variable contains 0. You should always initialize it. You're saying, well, why? I mean, if the documentation says they're setting it equal to 0, why do I need to set it equal to 0? That's just an extra line of code you don't need. What do they do when a new version comes out? We have no clue, do we? Unity, I was using a package called Unity that it's used for C# for game programming, and I was teaching out of it last semester. Had everything updated, brand new, from the latest version. And this semester, I had some students that downloaded the software, and I assumed it was the same version. It wasn't. They had updated it. And they told me the screen looks nothing like, what I was showing them. So then I had to update mine. And come Tuesday morning, it was Tuesday morning, I brought up Unity, and it was saying there's another new version out. So you don't know what's going to happen in the future. So if you're deliberately setting it equal to 0, you're ensuring that I don't care what they do. I'm setting it equal to 0. It will always be equal to 0. Let's see. You must at least initialize the first element to 0 for the remaining elements to be automatically 0. The array elements are initialized before program startup for static arrays and runtime for automatic arrays. Common programming error, forget to initialize the elements of an array. You might say, well, you didn't do that. You didn't initialize your elements of your array. We had 4, didn't we? This right here. If I get rid of this, if I put, I'm going to have 2 numbers. So I put in 3 and 4. Tells me the sum is 7. I didn't initialize those last 2 elements in my array. I don't know what they're equal to. Null, maybe. Does it matter for this program? Doesn't, does it? because I'm controlling exactly which ones I'm going to access. So I don't have to initialize those other ones. If you want to, it doesn't hurt. It's easy. You come up here, you initialize. Spell initialize array. You just say for int x equals 0, x is less than or equal to 3. Let me just say x is less than 4. And then x plus plus. And you say cx is equal to 0. So it's nothing exciting. You don't even have to put braces. It's one line of code. This would initialize everything to 0, going from 0 to 3. So how many numbers do I have? 2, and I got 3 and 4, and sum is still 7. So if you want that there, you can, but if you're going to control it this way, you don't necessarily need it. Watch us get down to the secure programming. They tell us that we have to do it for security purposes, but we'll see. Okay, we talked about that, initializing. This is a new where you don't have to put the size in. If you're initializing it to something like this, it can count. So it counts that there's 5 numbers there. And so it'll set the size as 5. Talk about a symbolic constant. This is where you define a constant. Constant doesn't change. So up here we do a define and we say our size is 10. What that means here is I come up here and I define size equals, or no, just space. Uppercase, since it's a constant, 4. Now, instead of hard coding this here everywhere, I say size. Here, I'd replace this by size. I don't see any more 4s. Benefits of this is it's in one place. Still runs the same. If I run this, how many numbers do I have? I have 2, 3, and 4, and that's still sum is still 7. So now if I need to change the size of the array, I just change it in one place. I change this to 40, for example. That way you don't have to search through and change it in multiple places and possibly miss some places. And then people are going away from your nice system called Blackboard. Still have 2 numbers, 3 and 4. Answer still sum, or 7. That's how you can use size. That's a symbolic constant. I don't think it has to be all uppercase. That's just kind of the convention that they assume. We already looked at that. The define preprocessor directive defines a symbolic constant size whose value is 10. Symbolic constant is an identifier that's replaced with replacement text by a C preprocessor before the program is compiled. So it goes through and puts 10 in everywhere it sees size, if it's set to 10. Common programming error: ending a define or include preprocessor directive with a semicolon. Remember, the preprocessor directives are not C statements. Just says you can't have a semicolon up here. No semicolon. Defining the size of each array as a symbolic constant makes programs more scalable. It's easier to manage them. As you increase the size, then you just can easily make the change. Is Excel limited on a number of rows? It is, but for the most part, if you want new rows, you just keep going down, right? Like that. Shift Control End. Where's the end? No. Control End. No. Shift End. No. How about if I just hold down the page down over and over? Probably crash the video because the video changes. So I keep on going down. There's a way to go to the very bottom. Let me go to B 1,000,000 or something like that. Doesn't like that. Oh wait a minute, that's changing the name of this. What am I doing? How do I go down? Control Home takes us there. Shouldn't Control N take you all the way down to the bottom? Obviously not. But anyway, I would eventually reach a limit as I kept on going down. If you keep going to the right, I can probably come with that limit faster. Now, it by default does not go ahead and assign memory for all of this. So again, it's allocating memory. Assigning a value to a symbolic constant in an executable statement is a syntax error. A symbolic constant is not a variable, so you can't change it. Compiler does not reserve space for symbolic constants as it does for variables that hold values for execution at time. Again, a preprocessor takes whatever number you put in there next to it and just plugs in it everywhere. That's all it does. That's why you can't assign it a value. Good programming practice, use only uppercase letters. You don't have to, though. Multi-word. Now, the benefits of saying it's all uppercase is when you look at it, you know exactly what it is. So you know where to look. You see the size all uppercase, you look up here at the very top. So it is good programming practice. Separate words with underscores. That's kind of true with any variables. You know, if I had something up here, define David's car miles per gallon. 32. I don't know what I get. This is what they're talking about. If you got multiple names, multiple words, you separate them with some or underscores. Makes it easier to read. Okay, we've already looked at summing the elements, so we'll go over that example. Good programming practice, strive for program clarity. Sometimes it may be worthwhile to trade off the most efficient use of memory or processor time in favor of writing clearer programs. Sometimes. Depends on what you're working with. If you're programming Windows applications like I've done, yeah, who cares? You know, there's plenty of memory. Some of you go into engineering. Yeah, it does matter there. You may not want it to look real pretty and you know, everything's lined up and clear and understand. You'd rather have it fast because you're not working with much memory, and so you can't be sloppy with your programming. Sometimes performance considerations far outweigh clarity. Well, there's the other one. You see there, got the frequency size in there, the array size defined, equals 0, and that automatically sets everything equal to 0. Here we're hard coding the responses. Oh, that's horrible. And then here they're including the value of this array as the index for this array. This sometimes works. I've used this in the past, but sometimes it comes back and bites you. Where I used it at is I would have like a int, and then I had customer number, and let's say I'll just hard code values 40, and then I would have int sales of I don't know, 50, something like that. And I would ask him for the customer number, so I'd get the customer number from the person. I'd ask him for the sales, and I would use these indexes to store it off. So not a very good way to do it. No, actually, I'm lying to you. I don't think I use customer number. I'd have this, and then I'd have customer number like that. This is assuming I have a customer number that is 2 digits. So then I would ask printf enter customer number, and they would do a scanf %d customer number like that, and then I'd say enter the sales, and I would say printf enter sales scanf %d sales. And how I'd store this off then is I'd say sales, and then I'd put in customer number here equals sales customer number plus sales. Although it doesn't help to have those both as sales. Sales amount. Sales amount. Sales amount. So if the person entered customer number 03, then your sales 23 or 03, you take the old value that's in there and I add my sales amount like that. That's what it would cause. Does that make sense on that? Now, it was never 2 digits though. It was 5 digits. You think of your largest customer number when you got 5 digits. 99,999. So instead of 50 here, I don't know why I've done this in the past. What's that do to your memory? Kills your memory, doesn't it? Because you got a lot of unused space. Now, it's very easy programming. It's very quick, but it's a horrible way to do it. Now, when I've done this in the past is, this is back at Coke, actually. I download mainframe data, and I wanted to present them a spreadsheet. And I wanted to create it without a database, because I didn't have a database with Visual Basic. I didn't want to use files. We're going to see files in this course, and they're clumsy to work with, and I want some fast method. So I use this. Believe it or not, this was when Windows first came out. It didn't like bring their machines down to a crawl or anything. So even back then, I could get away with sloppy programming. I knew it was wrong to do, but in terms of efficiency, there's better ways than that. But that's what they're doing here. And like I say, sometimes it makes sense because you can use the value here as a subscript for this other one. So, common programming error referring to an element outside the array bounds. Did I get an error when I did that earlier? No, it just let me do it, didn't it? I was kind of surprised by it, to be honest. Most programming languages won't like that. They'll give you some kind of bizarre error. I was kind of shocked when it did what it did. When looping through but realize that C was kind of the I won't say beginning programming language, but all these other ones are now C#, Java that are C based. They've come after that, and so they've added in all these bells and whistles to handle these programming errors, these hacking issues, and so forth. When looping through an array, the array subscript should never go below 0. It should always be less than the total number of elements in an array, size minus 1. Because remember, if you got 4 numbers, it goes from 0 to 3. So that's why it's size minus 1. Make sure the loop terminating condition prevents accessing elements outside this range. That's what I didn't do on my example. Program should validate the correctness of all input values to prevent erroneous information from affecting the program's calculations. And again, I didn't put that in my program, and that's why I got weird results. That one's not really worthwhile showing. Histogram with asterisks. It's not good. Here's rolling a die. That's not a bad example because it uses random numbers, which we talked about. But this is where you can simulate rolling a die 6 million times, for example. So if you get a chance, look at this one in the book. These are in the book. It's kind of a nice program. If you're going to math, I don't know. Has anybody going to mathematics? No. Is engineering? Computer science?
Yes.
Okay, you're going in computer science? Aerospace. Okay. Yeah, it's more of a math thing. Like if you want to do a simulation, you go into those, like you go into engineering, they got simulation packages where you can put in your parameters and so forth. I suppose if it's something brand new, you might have to write your own simulation, but a lot of packages out there for it. Anybody read about the Mars, what do they call it, rover? No? I didn't get to read the entire story yet, but it quit working. And they're talking to how it's supposed to only work for a very short period of time, and it's like been working for years and years. I guess it's been going around Mars and taking pictures. And when they sent it up there, they figured it would just be a very short period of time, and it'd be broke down or run into something, wouldn't work, and so they finally lost contact with it. So Martians finally found it and blew it up. Now here's character arrays to store and manipulate strings. Such that if you got the string hello, and you see you got your character string 1 and then equals first, initializes the elements of array string 1 to the individual characters in the string literal first. Let me clean all this up. So character string 1 equal to hello world. Now, this one, this has 5 characters in it. What do you think that's going to go from, index-wise, subscript? 0 to 4. Yeah. This one, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one go from 0 to 10. So again, the same indexing applies on these for your subscripts. This one's a kind of important piece of information here. Your string termination character. You see the character constant representing the null character is this /0. All strings in C end with this character. Character array representing a string should always be defined large enough to hold a number of characters in a string and a terminating null character. Character arrays can also be initialized with this individual character constant initializer list, but this can be tedious. The definition we had before. Remember how we had numbers with commas in between them? Well, you can put characters. So put single quotes around those. You can have characters separate. You just have to put this /0 here at the end. If you forget to do that, you get weird results. And that's a big mistake in programming. I forget that most of the time myself in putting that. Just because you don't have to do it in any other. Is that a true statement? Do you have to do it in any other language? I don't think so. Because a string is really an array of characters, we can access individual characters in a string directly using an array subscript. So for example, for int x equals 0, no memory. How many did we say was there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11, so 0 to 10, x plus plus. And I'll do a printf, and this really depends upon whether I can remember this or not. Is it C? Let's try that. And string 1 dot, or string 1x, like that. Hello world. '21. Hello world. And then we got some weird characters that are in memory. So again, this is the issue. Is programs not written correctly to where you can possibly overload it, go beyond the memory space, and who knows, do what. Let's see. We talked about the positioning there. This is how you define an array of characters. So you got character string 2, 20, and you got 19 characters, and then the terminating null character. So if I had character first name and size, let's say 20. Character last name, 20. So that's just how you declare that. If you've worked with strings in other languages, a string is just, again, an array of characters. So they've just made it easier for you to work with right off the bat. This statement, scanf %19s, and then your variable reads a string from the keyboard into string 2. So it looks like we do our %, the size, and then s. So here, if I said printf input first name, scanf, and I have to look this up because I don't got this memorized. Percent 19s, comma, is it a nope, f name. Printf, input last name. What? Because the last character is a string terminator. Okay. So that's why you got to save that last one to put that in. Percent 19s, then last name. Now, what did we always do before? Here, we put a and symbol, right? And we didn't do that here. They're going to hopefully talk about why. It says the and symbol, the ampersand, is normally used to provide scanf with the variable's location in memory so the value can be stored there. Section 6.5, when we discuss passing arrays to functions, we'll see that the value of an array name is the address to the start of the array. Therefore, the ampersand is not necessary. Some of the items, when you're dealing with arrays, they assume that you don't want to, you don't ever want to put it in as an entire value of a variable, for example. So you don't want to consume all that memory with a bunch of variables. So instead, it automatically just points to the memory location. So, for example, if you're calling a function, you're passing in, I gave this example last time, I think, you're passing in 10 million array entries. If you're passing it by value, you're passing each one individually. And if you're calling that function 1,000 times and all of a sudden your program is just consumed with trying to manage the memory. So instead, you pass the location of where that array is stored at into your function. And we'll see examples of that. It's your responsibility to ensure that the array into which string is read is capable of holding any string that the user types at the keyboard. Function scanf does not check how large the array is. Thus, scanf can write beyond the end of the array. And what's beyond the end of the array? Memory, right? So you're writing into memory. What kind of memory are you overwriting? I don't know. Typically, the way memory works on a computer is the computer sets aside its own memory space. It's more detailed than that, where it breaks it down. And then you got your space down here that you can use. So when it overloads the memory, typically, if it's a Windows machine, it's not going to like corrupt your memory and cause you to reboot and so forth. Famous last words. Let me try to overload it and see if it blows up my machine. Okay, let me run that. Enter first name. My name is David, and there's spaces here, which should cause problems. Maybe. This is really long. Never even got to the last name. And the reason why is I had spaces in there. David Hayes, whatever is my name. Enter. Didn't get to my last name, did it? I didn't put any spaces in that time, so it does weird things. Assuming I have it programmed correctly. Let's try to put in David Hayes. Works fine, doesn't it? That's what it's talking about, is that you need to manage that in your program. Otherwise, scanf, it can do whatever it wants there. Character array representing a string can be output with printf and the %s. So that's how we do the printf, is with %s. Oh, the null terminator. Characters are string are printed until terminating null character is encountered. So that's handled automatically. Okay, so we bring that in, printing off the string. That's nothing too exciting. This is outputting characters until a null character is reached. So let's take a look at this code. So that's a unique. So I'm going to say for int I equals 0, I is less than size 20. And string 1. No, fname. Fname I is not equal /0 semicolon plus I and printf %C. We're doing this a character at a time. That's why we're going back to our %C. If you use the %S, that's where you can print the entire string. And then we're doing a space after that. And saying fname I, like that. Okay, so let's run that. Maybe. Bring down my program. Now run it. David Hayes. And it prints DAVID. Okay, now what this is doing, it starts the at 0, because that's where your array starts. Always starts at 0. Both of these have to be true. I has to be less than 20, which means less than 20. Yeah, that'll still work. Because if our string is 20, our array of characters is 20, I could have 19 characters, and my last one's the null terminator, isn't it? But that'll still work because we got this and here. So this has to be true, and this has to be true. And this one says that current character cannot be the null terminator. So that's why this ignores a null terminator. And then this is increasing our I each time through. Questions on that? No? If I get rid of that, let's see what it does. David Hayes. It's accessing memory outside of that. Because David is 5 characters long, the null terminator is at the 6th position, which is actually the 5th, because it goes from 0 to 5. I know that's kind of weird. You haven't seen it before. So this is our 0th position, 1st position, 2nd position, 3rd, 4th, and 5th. So when I take out the check for that, fname I is not equal. /0. I think it was not equal. David Hayes, yeah, not equal. What this means is when it encounters that /0, it stops right there. It does not do any more characters. So that stops your for loop. We haven't looked at putting the and in here before, but that's how you would stop this if you're going character by character. Again, you don't have to. I can print my first name using the %s /n, and then pass in, do I need to, I think just F name. David Hayes, and just prints David. Sometimes you want to process it a character at a time, though. So this bit of code right here is where we're processing it a character at a time. This is where we're processing it all at once. This is a string. Well, where would this be used at if you're doing a character at a time? I volunteer teach for University of People, and they offer free degrees for people across the world. Try to give everybody an opportunity for a better life. And I also do some training for them for new faculty. And this spreadsheet they have has this as one column. So they have David space Hayes. That have Sally space Williamson. They have Ty whatever. Sampson. Drawing blank on names. Can I sort by last name with this? No, it's horrible. When I was updating the sheet, there was another trainer, and she would be updating at the same time I would. And so I'd do the filter in Excel, so I could just filter just mine, but still it was horrible to do. And then she would set the filter on her side, and we kept going back and forth, flipping it to my name and to her name. Finally, I just gave up, and I put both of our names in for the filter. And why in the world they'd put first name and last name into one column, I don't know. But that happens in life. I could write a program to split this apart into two separate strings based upon that space there. You could do it a character at a time. That's one method, and that's an example of where you'd use it. Let's see. Static local variable exists for the duration of the program, is visible only in the function body. We can apply static to a local array definition, so the array is not created and initialized each time the function is called, and the array is not destroyed each time the function is exited in the program. This reduces program execution time, particularly for programs with frequently called functions that contain large arrays. And we'll see an example of that. Make the array static so it's not created each time the function is called. What they're saying, and I won't create an entire one here, but you have a function down here. And or void print it, something like that. You have this down here, and you have a you have an array declared down here. If you call this print it 1,000 times in your program, if this is just like a normal variable, this will sit there and reallocate that memory over and over. So it's not very efficient. If instead, and we'll see an example of it, if you specify that static, then it won't do that. Let's see. There it is. Make the array static so it's not created each time the function is called. So it's a performance technique. Assuming that the elements of a local static array are initialized 0 every time the function which array is defined is called. Assuming that seems to be missing something there, doesn't it? Assuming that the elements of are initialized, which is defined as called. Oh, that's just common program here. Never mind. Okay, so here's some of our calls. Easy to declare it. You just put static in front of it, and that way it doesn't keep redoing the memory. So that's how you do it. Here's your automatic array. See how there's no static in front of it? So different ways you can handle it. Maybe sometimes you want to reset it to different default values. This is automatically resetting it to 1, 2, 3 every time it calls this. And let's see. Here's how you pass arrays to functions. Pass an array argument to a function, specify the array's name without any brackets. For example, if array hourly temperatures has been defined as this, the function call would just refer to hourly temperatures is how you pass in the array. This is just passing in the size. C automatically passes arrays to functions by reference. I don't know if you can undo that, really. We'll see that in Chapter 7. This is not a contradiction. Called functions can modify the element's values in the caller's original arrays. So again, it's not passing in by value. You got your huge array here of 10,000 elements stored in this location in memory. Let's say it's at memory location 100. It's not, but it's at 100. So when you call a function, you're passing in the location, that 100. And so then your program can then go and access that actually in its location. Versus, I give one of you a piece of paper, and I tell you I want you to change it in some way and give it back to me. You make a copy of it. So you got your own copy. You make that change. You pass me back your copy. I then have to take that and I have to modify my original. So I don't let you actually change it. You actually make a copy. Now the by reference means I give you my piece of paper and I say change it on the piece of paper. You change it directly there. Does that make sense, the difference between the two? And again, most programming languages assume that you want to pass it by reference, just because it's from a performance standpoint, it just makes sense. Therefore, when the called function modifies array elements in its function body, it's modifying the actual elements of the array in their original memory location. And we'll see that here in a minute. But this demonstrating an array name is really the address of the first element of the array by printing these. Haven't looked at our program yet. Passing arrays by reference makes sense for performance reasons. I keep saying that over and over. Okay, or I do anyway. And this talks about the different parts of this. So we got character array of 5. And we do a printf and %p array printf percent nope, and array, so that has to be in quotes, and array 0 /n, and oh no, I'm reading that wrong. What's the last one? %p again. Okay, %p /n and array. So if I run that, yeah, I did something wrong. Oh no, they're all the same. Okay. So demonstrating an array name. Oh, they're just showing doesn't matter how you access it. So the address of the first element of the array by printing that. So when I pass in just the array name, it comes back and tells me where it's stored at in memory. I'm asking for the first entry. It's come back and tell me where it's stored at in memory. If I'm actually doing the AND symbol there, and that AND symbol, remember from the scanf, was accessing memory directly, then it's returning the first location of memory. So they're just really emphasizing that when you're working with arrays, it's just automatically going to your first memory location. Okay. See, I don't think I've ever done this. It's possible to pass an array by value by using a simple trick we explained in chapter 10. Though entire arrays are passed by reference, individual array elements are passed by value exactly as simple variables are, because it's just one element. Here's the general format. When you call a function, you pass in the array name and type, and then you pass in the size of it. It's probably not a bad place for a 10-minute break. We've been going an hour and a half. And then I'll write a program that passes in an array of numbers and adds them together into a function. So nothing new. We've seen that, but we'll see how to implement it with code.
How's your son? Is he doing okay?
Yeah, yeah, he's doing good. I'm happy. No seizures.
Yes, we're all happy then.
Sometimes, I guess when you get a concussion, you can have seizures.
Yeah,
So I'm happy that didn't occur.
that's good. That's good news.
I want char. IG. Define size. No memory. Define. Maybe I can't use size there. Okay, so print array nums size double array nums size print array nums size. Two, three, four, five, 4, 6, 8, 10. Okay, let's go ahead and start again. I worked up a little code example for us to look at to see what do they mean exactly. I declared size to be 4 up here. That's the all uppercase. Then I got two prototypes here. And I got double array. And what I'm going to do with double array is I'm going to double the numbers in the array. And then I got print array, where I'm going to print the values in the array. Now notice that I'm passing in size there. But the size I'm passing in is all lowercase. That's a different variable. It has nothing to do with that defined constant at the top. I actually tried to pass in that constant at the top. It wouldn't let me. Which I was kind of surprised about, because I thought preprocessor would go through, and everywhere there was uppercase size, it would replace that with number 4. But it doesn't work on prototypes, I guess. So then I just create a real basic array, 2, 3, 4, 5. And then I print it so I can see its original values. And then I double it, and then I print it again. When I'm passing in, I'm passing just the name of the array, not brackets or anything, and then the size, so I know what to work with. Then down here, I'm just looping through. For x equals 0, continue while x is less than size, x plus plus, and just print out the result. And I'll put them all in the same line. So when I run this, 2, 3, 4, 5, 4, 6, 8, 10. So that's how you pass it into a function so you can use it. And keep in mind, when you're passing this in, you're not passing in the actual value. This is the actual value. So it's taking that, it's passing that as a parameter, it's setting aside memory space for it when it runs a function. So it's consuming two spots in memory. It's got the original spot over here. Well, no, this is hard-coded, isn't it? Because it'll plug 4 in. But if this wasn't hard-coded, if there's a variable over here, there'd be this memory allocated for that variable, and then where I bring it in would have memory allocated. But the array doesn't do that. The array just points to the memory location where it's stored at, always. Except for in chapter 10 where you do that weird trick that I don't think I've ever seen. Is there any questions on passing in an array to a function? It's a fairly simple idea. It's kind of hard to work with after that, though. This indicates you can modify the array. We did that. Sorting arrays. This is probably one of the most challenging classes I ever took. If you go into computer science, I've taken it, probably. But it's a data structures class. If you go to Wichita State, it will be a data structures class you have to take. And it was fun. All the different ways that you can sort something. Well, let's take a look at some sorting. Close that. Probably consuming a lot of memory. New. Okay, so I got 5, 1, 7, 8, 2, 3, 4. What's my first number? If I sort it. 1. So that's my first number, going from smallest to largest. Now I did that by scanning through here and finding the smallest number, right? So I did 1, 2, 3, 4, 5, 6, 7 comparisons. Maybe 6. What's my next number? 2. So again, you went through here, scanning this, knowing I'd already used this, and you found 2. So that's one method. That would consume a lot of memory to do that. And I don't even know how you'd program that, to be honest. One method of sorting is you compare this number and this number. And you ask if this number is greater than this number. Or you could ask if this one's less than this one. But is the second number greater than the first number? No. So I'd swap them. So I'd swap them like that. Now, I have like a pointer here. So that's pointing there. And I'm comparing this number to the next number. I move my pointer down. So I move my pointer down to here now. And you're comparing this number to this number. Is this number greater? It is, isn't it? So I don't make any change. And I move my pointer down. Now I'm comparing this number to this number. Is this number greater than this number? Yeah. So I don't make any change. Now my pointer's here. And I'm comparing these two. Are you always comparing this number to the next number? Is this next number greater than this one? No. So I'm going to swap them. So I got 1, 5, 7, 2, 8, 3, 4. And I move my pointer down. Now I'm comparing this one to this one. Is this second number greater than the first? No. So then I swap them. 3, 8, 4. Now my pointer is right here. And you never go to the very last number because you're always comparing to the next number. So I'm going to compare these. And again, I have to swap those, don't I? So 1, 5, 7, 2, 3, 4, and 8. Now I start over. I come up here and put my pointer up here. Well, that's okay, isn't it? And I won't write down all the steps, but come down here, move my pointer down here. Comparing this number to the next number, that's okay. Come down here, put my pointer here. Those need to be swapped, don't they? So I got 1, 5, 2, 7, 3, 4, 8. And my pointer is now down here. These need to be swapped. And so on. So you continue that same pattern and comparing that number to the next number and then swap them. So that's one sorting technique. That's pretty disappointing. 200 slides and they can't show the bubble sort. Maybe the book shows pictures of it. I don't know. What do bubbles do in water? They float to the top, don't they? This process has the smaller numbers float to the top because they're lighter. I don't know. And the larger numbers float go to the bottom. They call this the bubble sort because the smaller values gradually bubble their way upward to the top of the array like air bubbles. Now there are tons of there's a whole class of techniques just about sorting and searching. And other techniques also. But this is one you oftentimes see in a first programming class, is how to program that. Well, let's think about how to sort this. First off, our index started at 0. So index started at 0. And then my index went to 1 less than my total number. So, and I may have to cheat and look at the code on this. Sometimes I get this, sometimes I don't. Of course, this is already sorted, so that's not good. It's not sorted. Let's see, 5, 1, and 7. And I'm going to have a sort array. Let me get rid of double array. Sort array. Nums and size. And I'm going to have void sort array. Int in. Int. By the way, I'm not going to assign any bubble sort. But if you like a challenge, program the sorts they have in there. I'm not sure how many they actually have in the book. Void sort array. Pretty much you always can do a void because you never need to return the array because it's passing it by reference anyway. So almost all the time you'll see those as voids. Now I'm going to have a variable called passes. Pass. And pass is going to equal to size of my array. And I have to think about this. Like I say, I don't get this right the first time usually. If my size, if I have a 4, then and I want to go from 0 to 1 less than the size. So it's normally 0 to 3. So I go 0 to 2. So this will be size minus 2, I think. Now I'm going to do a loop here for int x equals 0. Continue while x is less than or equal to pass x plus plus. Now I'm going to need another variable for temp. This keeps like a temporary copy of your array entry. And now you simply do an if statement here. You say if that entry, we did it, well, I said it differently, didn't I? Say if the next entry is greater than the current entry. X plus 1 is the next entry. Greater than? It's supposed to be greater than, isn't it? It's less than. That means that when I compare these, shoot, here it is. When I compare it like that, I'm comparing the next entry, which is 2, to the current entry, which is 8. And so I'm checking to see if the next entry is less than the current entry, which means I need to swap them. So if that's true, then we're going to swap them. Well, first off, I need to save off one of them. Doesn't matter which one. So I'll save off x plus 1. And then I'm going to say n of x plus 1 is equal to n of x. So I'm setting one equal to the other. And then n of x is equal to temp. Okay, so then that'll go through, and I'll print my array, and let's see what happens. It's not going to work, but let's see what happens. 4157. what did it do? It swapped the 5 and the 1, didn't it? Which it should. 4 and 5 was in the right order, so it left it alone. It hit the 5 and 1 and said, wait a minute, 1 is not greater than 5, so it swapped them. And then when it swapped that, it compared to 5 and 7 and said that's okay. So actually what we need to do is this just does one pass through it. Remember how I went through here and I had my pointer keep going down, but then I got over to here and somewhere I started again. I think this is where I started again. So we need to do it more than once. This is the part I never get right. I probably do it quite inefficiently. You have another for loop up here. int y equals 0. Y is less than or equal to pass. And I don't think you have to do this many iterations. But it doesn't hurt. Well, again, I'm a sloppy programmer. I'm not like an engineer that things have to be efficient. I don't think I'd survive in engineering. Yeah, probably not going to survive lining these up. Okay. So that's going to loop through that. It'll loop through that. Let's run it. 1, 4, 5, 7. So it's not sorted, isn't it? Now let's make it worse. Let's make it, just to show you it works, 8. And then I'll have a 15 here, and then I'll have a 2 and a 3 and 1, 2, 3, 4, 5, 6, 7, another one, 4. Run that. 1, 2, 3, 4, 4, 5, 7, 15. So it's not working. Once you've done a bubble sort one time, and if you understand the concept of how these this pointer's going down, then you just think of that pointer being a for loop. Then it's not that bad to implement. Now here's the way it should actually be programmed. I'm sure that they do it right. For pass equals 1, you do pass is less than size. But then this next one is pass is less, or I is less than size minus 1. And I don't think they did it the most efficient way. Somehow you interchange these variables. And I don't remember how you do it. Maybe not. Maybe size minus 1 is the only way. But anyway, that's a bubble sort. There. Now, do you think that would work very well if you had 5 million records? No, that'd be horrible. Another way, and we're not going to look at it because it's quite evolved, although they might have it in the book, is consider that this row here is the memory location. My smallest number is the 1, isn't it? So from the very beginning, the way you design it is this has pointers. So here, this is going to be a pointer to the next number. Well, if I look at my smallest one here, what's my next number? 2. So I put the pointer here of where the memory location is. So that's pointing to 14. Now here, my next number is 3, which is at 15. So that's pointing to 15. My next number here points to 16. That's the next number. Next number is at 10. Let's see. And this one points to 12. And this one points to 13. And then this one has some kind of null termination or something. don't know why it won't let me do a slash. It just keeps doing that. I don't know, that's some kind of null terminator there. Now, when you design this from the very beginning to be sorted this way, well, then all you have to do is follow your links to see how to print them, right? So you don't have to sort them each time. If you insert a new number, like I now want to put 1, 2, 3, 4, 5, I want to put 6 in there. For a normal array, you'd have to, if you got 5 million records, you possibly have to shift 5 million records to put that in the right spot. So it's an assorted array. Because you don't want to sit there and sort it each time you run a program. You want it to be sorted to begin with. With this type of pointer system, you're just going to put it down here at the bottom. It doesn't matter where it's at. So I put 6 there. And then I start going. I start my first one, and I compare that 6 to the 1. 6 is greater than 1, isn't it? So I go to my next one. This says 14. So I come down here. I compare 2 to 6. Well, 6 is still greater than that. So this points to 15. I come down here. 6 is still greater than 3, so that's good. This goes to 16. Come here. That's still good. This goes to 10. I'm right here. I'm still good. 5 to 6. This goes to 12. But right here, this number is greater than this, isn't it? Which means I take this pointer here. I put it down here. Wait a minute. Let me think this through. Okay, this points to 12. So I now want this to point to 17. So this will point down to 17 down here. And then I want this to point to here. So that'll point to 12. And that points to 13. That's correct. Now, how many changes did I make there? 1 here. Whoops. 1 here. 1 here. I'll get it right eventually. I made 2 changes, didn't I? That's the way oftentimes a file system, a database system is arranged. You know, you have it pointing. We talked this morning in the introduction to the forensics class about file storage. And the idea there is that you have pointers where it points to this and this, so it can very quickly traverse through it. If it had to sequentially go through every bit on a hard drive, it wouldn't work well. Anyway, probably more than you want to know about sorting. That's also an efficient way of searching, too. We already talked about sorting there, sorting. I'm not going to go into any more than that in terms of the bubble sort. In case you're wondering how many sorts there are. How many sorts for an array? There's quick sort, there's heap sort. Someday I'm actually going to go to a virus when I do this. Here they are. Selection sort, bubble sort, recursive bubble sort, insertion sort, recursive insertion sort, merge sort, iterative merge sort, quick sort, iterative quick sort, heap sort, counting sort, radix sort, bucket sort, shell sort, Tim sort. Why isn't there a David sort? Comb sort, pigeonhole sort. You think you could just spend an entire class, 16 weeks just on sorting? Yeah. So tons of different techniques there are to efficiently sort your data. I'm a sloppy programmer, so what I did is when I was working with Windows packages, I'd drop every one of those numbers that I want sorted into a list box. And then a list box, if you ever programmed in a GUI, has a property that says sort or sorted or something. So you set that to true. You drop your numbers in there and it sorts it automatically for you. I have no clue what sorting technique it used. It wasn't the most efficient, but again, you can get by with that when you're programming Windows. By the way, you may have looked at this and you say, well, big difference. You know, you put pass here, you put pass here when you should have put a -1 here, I think. You said, what's the difference? Well, no difference when you got 4 numbers, right? But if you have 5 million numbers, maybe a huge issue there. So you may have a real performance problem. Okay. Let's see, sorting. That's just finding the mean, median. Could find a standard deviation. That'd be kind of fun. Yeah, let's do standard deviation. Well, maybe I have time. But I'm running out of time quickly. Okay. Searching array, because we're probably not going to get done with this chapter tonight. By the way, how many searches do you think there are? Probably the same amount, like 100 or something like that. I like the binary search, and I really want to focus on that, but I don't know if I can get that in tonight. Linear search is a common one. So searching array. May be necessary to determine whether an array contains a value that matches a certain key value. Process of finding a particular element is called searching. Linear search. Well, you can probably guess what this is. Okay, so I got my array of values here. And I want to see if there's a number in there, like 15. So I'm going to need a search array. I'm going to pass in the array. I'll pass in the size, and I'll pass in my search value. Down here. You know, actually, I probably want to do a void not a void I would want to return something, but I'll use a void just so I started. Search array and in size search value. Well, very easiest way is we have a loop here for int x equals 0, continue while x is less than a size or equal to. Let me see, size would be 8, so I'm going to go 0 to 7, 4, 5, 6, 7, 8. Yeah, 0 to 7. So less than size, x plus plus. And I'm going to check if the that particular array entry is equal to my search value. If it is, then I want to do a printf. I found it. So it's just going through it linear search, item by item. And up here, maybe I would ask the user for what number they want. What number do you want? And S value, and then I'm going to do a scanf, %d, and S value. Then I need to call search array, and I'll pass in my my array, comma, my size, comma, my search value, which is S value. Okay, so this is just going through it sequentially. It doesn't even stop after it finds it. You know, because if you have found it, do you need to go through the rest of the array? No, I'm a sloppy programmer. I can get away with that. What number do you want? And I'll put in 21. Didn't come back. I didn't find anything because I don't have 21 in it. What number do you want? I want 15. Comes back and says I found it. And what do you think about this? Is it very, very good performance-wise? No. I talk about working at Coke in here and saving the company like $250,000. Okay. I worked at Coke Industries, and this is a computer science. It's really interesting. So I worked at Coke Industries, and they had a mainframe that they made monthly payments on. They're leasing it or buying it, I forget what. They made monthly payments. So they might pay $100,000 a month. Let's say they paid $100,000 a month. Well, I had this idea that I need to go through and fix reports for people. So I'd go through and look at their reports that they're running at night and see if I could improve them. Any ad hoc reports they were running, I'd improve them. For example, one report that I created was costing them $400 per run. And it would take them 4 or 5 hours. They'd run it at night, which is fine with them, but it cost them that much per run. I took it down to where it cost them like 50 cents per run. Did this for maybe a year, making all these improvements. Got this letter from manager Coke saying David's the best thing ever. David has saved, and so I know some of you have heard this maybe. David has saved the Coke Industries $250,000.
So you get a bonus?
No, but they were patting me on the back, saying, fantastic job, keep up the good work. I went over to
That's just not right.
I went over to crude oil.
Saving them like $300 per run.
Yeah. Went over to crude oil, and I said I want to improve your reports. I want to optimize them. They told me you have not saved the company 1 penny. They told me I hadn't saved them 1 penny. They said they'd like me to do other work, but they don't want me to look at the reports. Why didn't I save them 1 penny? Why didn't I save Coke Industries 1 penny? They were right. How much were they paying for the mainframe each month before I started? $100,000. How much were they paying for the mainframe after I got done per month? $100,000. It's still a lease. They're paying that much per month. I did not save Coke Industries 1 penny. What I did is they were charging them per CPU cycle. And so they just had to raise the price of the CPU cycle. They had no choice. They're still going to have to pay this $100,000 a month. Talk about a blow to your ego. I kept that memo because they were right. It's a perfect thought process of logical thinking, business, and so forth. It wasn't that I didn't even save them 1 penny. During that year, I cost them probably $100,000. How did that cost them $100,000? Salary was probably about, I'm guessing, $50,000 if I remember how much I was making. Salary was $50,000, and projects I could have been working on, projects that were of value, were probably $50,000. If your salary is $50,000 and the amount of money that your projects are saving the company or the benefit they get is only $50,000, do they need to even have you there? No. Same amount of money they're paying for your salary is how much you're saving. It's just like, well, send you out the door and we don't need you. So yeah, I cost them $50,000 that year, went in the hole. But it's interesting, things like this. Well, this $400 per run, the reason why I bring up the story, this was sequentially going through the database, and it was a table with 5 million records. It wasn't using the index, so it was easy change. I went in and I had to use an index, kind of like that pointer type system where it knows to go to. And so when they were doing a search or a sort in the report, it would then do it not sequentially, but it would use the index, and so it was very fast. Yeah, it's interesting. Some of the things you run across in computers. Now, do you think I went back to my manager and told him this? No, it's like I wasn't gonna go back and admit that. But crude oil was right. I love crude oil. They really had a good business sense to them. The linear search compares each element of the array with a search key. Because the array is not in any particular order, it's just as likely that the value will be found in the first element as it is the last. On average, therefore, the program will have to compare the search key with half the elements of the array. I told you earlier in the course I hate breaks. This is one place. Let's see if I can even do the break right. I haven't done one forever. This is one place, assuming I'm putting it in the right location, where if you do a break, then after it finds it, it'll break out of the for loop and no longer do the rest of those iterations. Again, I'll never use a break in real life, so but I'd rather do it inefficient than to use a break. This shows the linear search here. Not much different than, there's only certain ways you can do it. Okay, they're issuing a return right here, so that would be more efficient. The return actually breaks out of the for loop ungracefully, but of course I didn't do a return, I just did a print. Now we'll start talking about this, but I'm actually going to save this for next time for the binary search. This is assuming your data is sorted. And you see talk about the horrible part of linear searches. Okay, I'm thinking of a number. Between 1 and 200. And Dawson, I'll pick on you. What number is it? 165. No. That's high, actually. What number is it? 56. That's low. What number is it? 125. That's high. 82. That's low.
100.
It is 100, actually, yeah. The binary search is such, and I hear this on radio stations. People call up and they're guessing the number or something like that, and it's like, oh my God, you guys aren't using the binary search technique for this. What you do is you first guess if you're looking for a number. So I'm looking for a number. What you do is you look at the number exactly in the middle, which, like you say, is it 100? And let's pretend that the number I'm thinking of is 82.
We had that game that we play
Where you halves.
lower, higher, and
Yeah.
stuff like that.
So this is high. So then you've narrowed it down, and you're looking between 1 and 100, right? Though actually, efficiency-wise, you wouldn't need to even use 100, but let's use it. So then, what's halfway between 1 and 100? 50. I'd say that's low. So now, since that's low, we're actually comparing what, 51 to. Well, let me use 50 just to make my math easy. 75, and you say no, that's low, and then so then you're looking between 75 and 100, and I can't really split that in half, but you get the idea. That's a principle of a binary search, and it's actually a very efficient way to narrow down with as few as possible comparisons. It's not like a linear search where you're comparing each item. And it's kind of a fun one. It's not that hard to program. Search an array with a binary search. Linear method works well for small or unsorted arrays. However, for large arrays, linear search is inefficient. If array is sorted, the high-speed binary search technique can be used. Binary search algorithm eliminates from consideration 1/2 of the elements in a sorted array after each comparison. The algorithm locates the middle element of the array and compares it to the search key. And then if they're equal, the search key is found. If they're not equal, the problem is reduced to searching 1/2 of the array, and then it continues that process. In a worst case scenario, searching an array of 1,023 elements takes only 10 comparisons using a binary search. That'd be like somebody on a radio program saying, I need to call in, guess the number I'm thinking of. And that says what people call in, they start guessing all kinds of weird things. Is it 1,021? No, that's too high. 1,020? We're going to be here a year. And this talks about the efficiency and so forth. That's not saying that the binary search is the most efficient one. It's probably the most efficient one that's easy to program. Now here, it says for a 1 billion element array, this is the difference between an average of 500 million comparisons and a maximum of 30. So you can see it's pretty efficient in that regard, isn't it? And to be honest, I haven't had that data structures class in probably 30 years, so I don't know. Maybe it is the most efficient one. I don't know. Let's talk about it. We're going to talk about how to code it next time, which is what this is getting into. Okay. We'll go ahead and stop there because I want to give time for any questions you might have. Next time, spring 2019. Let me go ahead and stop the recording.